Welcome everybody to this wonderful event here. Quickly, the title, a very exciting title, is about signals in Angular, a developer preview of a new feature that already landed in the next version, so we can install and test it. I assume all the open source library maintainers already do that. At least we, with RX Angular, already have our working concept, so we are pretty confident that we can immediately release a working version. But before I get to the point, I want to give a quick recap because I try to be here every year. I really enjoy to travel through India, and last conference I warmed up a little bit for my talk, warming up the voice, and then I had a pretty nice trip for around 2.5 weeks. This beautiful picture is from Rishikesh, a place that I also try to visit as often as possible. And this year, I'm here again. I'm extremely happy. We have also a couple of other people in that car that I really enjoy that will also give a couple of very interesting talks about IRC, LCP, and Walter will talk about some lazy loading, I believe. I'm not 100% sure. And okay, where do we start? On GitHub there are spaces, and one of those spaces in the Angular repository is titled Watch That Space, Angular Reactivity with Signals. It was very recently published, and since then the internet got wild. Let me quickly introduce myself. My name is Michael Hladky, but we can stick with Michael or Michael as it is easier than Hladky. I run a company called Bushbased. We do consulting, training, development and workshops in Angular, and we also focus on performance in pretty much any other framework out there. But back to the topic of signals. I want to quickly give you an overview what they promise us. So they promise us with this new feature, with this new built-in reactivity block, we can unlock something that they mention here as fine-grained reactivity. We can unlock the first approach to writing fully zoneless applications, and we can simplify a couple of other things. Angular's new version of signals will be lazy. They will have a more clever way to clean up their management, dependency management, and another very interesting side journey of this whole signal story is the Angular team wants to make a better integration story for RxJS. Things that I really enjoy because I'm a very big RxJS fan, and all of the things that you see here on the summary, for example, this fine-grained reactivity and the stuff, we shipped those features already 3.5 years ago with RX Angular, and this is one of the reasons why I'm so extremely happy that now officially it will also land in the framework, not just in the library. What happened in the meantime? Our colleague Enea, before they merged the PR, pulled out the signals code, brought us a stack blitz. Brandon started already his router-based signal stuff. Alex from the NGRX team is also here, and I'm pretty sure he has a little bit of proof of concepts, also using signals in NGRX. We have Sander that gives us a www explanation on what it is. Sarah had this really fancy website that explains how to use signals, and I'm not sure when you went to bed yesterday evening. I stayed up until 3 to watch this video here, a discussion session between Ryan, Pavel and Alex. Pretty interesting. It is recorded, so you can watch it anytime. I really suggest to do that. Okay, let's start with where's the magic in signals, because if you look at that code, you maybe will realize that sometimes it looks a little bit magic. and I will try to pitch you why it sometimes looks a little bit magic. So, in my application here, I can create a new signal, and I do that by writing the word signal, open closing brace, and I have to provide an initial value. I'm not a big fan of an initial value, but I did not design the whole concept here. And this value you can basically set and get. You can say, give me that value, so when I just call that signal, I will get the value. And I can also change the value. I can say, please set me the value of that signal to a new value of 2. Set and get. And those two things is the only thing that is publicly available, like for the public API of a signal. I can then put that signal here in my template, and if I would click that button, no surprise, the number goes up and down, but this is not really cool, right? It's a set and get method on an object, nobody is surprised. Cool, me neither. So, where is the surprising stuff? To basically get reactivity with signals, we have to subscribe to signals, and I will write a little bit of code and then I will discuss it step by step. I will create an effect, and this effect has a callback function, and this callback function basically can do something. For example, it can console log me the current count value. And if I do that, and I will look in my browser's console, I will see the number 0 here. And if I click that button, I will see the number 1. And this obviously goes on, and this was interesting for me. I was like, where's the magic? Why is this line of code here working? I call a function, I have a 0 argument void function in the middle, and that's it. And whenever I change count, whenever I set a value to count, this function here executes and I get another console log. How's that working? I tried to understand it. It was not so easy from looking at this line of code, so I read the source code. It's a little bit easier then. And I will try to pitch to you how this is working. Okay, let's start with this general idea of signals. A signal is a thing, a piece, an object, a whatever, that you can set a value on it and you can get a value out of it. I go from top to bottom, I initialize my signal with this initial value that I personally don't like, and then we call that signal, and what we receive is a signal that I named here with number, with my num signal, and this signal has a small gray box at the bottom attached, and this small gray box is a list. This small gray box is a list of observers. And whenever I set the value of a signal, in the next line you see, after I updated my value, I go to this list of observers and I notify every single observer in that list. In this list here, the observers are empty, no observers. But I would notify all of them if there is a single one. So how's the connection made up? There's another global variable, and this is in the slideshow here called active context. I'm pretty sure there are other wordings for that, but this is my wording. There is a active context, a active executing computation effect, whatever. And when I set, when I get the value out of my number signal, I, at the same time, go to this to this global variable and pull in the dependency, pull in dependence of my signal. Here are no dependence, but I will show you how dependence look like. We learned a signal is a set-get method, but it is not only a set-get method, it is a set-get method that notifies its observers. So what is this effect? Now it starts to get interesting. I create a signal, first line. I have this object where I can call set-get on it, and then I create something that is called effect. And a couple of people started to believe that this effect is identical or very similar to .subscribe from an observable, and I will show you that it is not very similar. It is maybe in the area of subscription, but there is more to it. So I have my signal, I have my effect. In this effect I have my zero argument void function that I call, and inside of that function I have a console log that gets the value of a signal. So if I go one step back, already here, before I execute that lambda function, I put myself as an effect up in the active context. So if I as an effect start to execute, I say I'm the active context, I move a reference of myself in this global variable and say, just that you know, I'm active at the moment. And then I start to execute. And inside of me as an effect, I call this signal, and we know from before, whenever I get a value out of my signal, I also go to the global context and pull in the active context and put it in my observer list. So when I get the value in an effect at this very moment here, I make the connection and I pull in active context in my observers. And when I set this value again, now I have an observer, I notify all the observers. And when I did it, all the limbo starts again. And I have again active context, put myself as an effect there, get the value from a signal, and register the connection. And this is done over and over and over and over in our applications. So, the learning effect is not really the stuff that is subscribing to my changes, but the getter inside of an effect or inside of a compute that is responsible for building the connections. Okay, building the tree basically. I can have an effect depending on two different signals. Easy, right? I just have two getters in my effect. I can have two effects depending on the same signal, then this same signal has two dependents, two observers that it will notify when I set this one signal, and those effects will get executed. This is basically the general idea of an effect. Okay, now let's go to computed. I have my count signal, I have my effect down here, and now I will create a computed. And what I do in my computed is I pull out the value of my count. Maybe you already realized this line here, this piece of code that I marked is responsible to put this computed in the dependence of the count signal. I split the value so that if I have multiple numbers, they will show up as single digits, and then I put that, too much scrolling, and then I put that stuff here, okay, say star, let d of digits, I call that function, here I can now place d, and if I run it again, I should see something, hopefully. Oh, where is the problem? Do I need to import ng4? ng4 is not closed? Thank you. Line 15 is not on the right line. But now it is still not working, I believe, because I don't have it imported. So let me quickly go up. I know this is a very bad live coding. ng module in common. I see that this is not common. Oh, that's a little bit sad now. So, let's hope this works. ng4, ng4, save it, and now it works. Phew, I was a little bit stressed. Okay, I clicked that, single digits. Now I could split it, boom, 2 digits, now I have these 2 digits. They are not nicely styled, but you get the point, right? So, and this, by the way, is not really surprising that it works because we still run in zone, right? So I will show you now something pretty cool. I will turn off zone. And I will go here. I could like go and completely kick zone outside of my application. Obviously, this is not possible in practice. You will break everything else. So RX Angular already a couple of years ago shipped strategies to migrate to zoneless. One of them is the unpatch directive, and I can quickly use that. I can put the unpatch directive on this button here, and then this one single button is decoupled from zone, will not interfere with zone again, and if I click this update button, nothing happens. Nothing. You see the console logs because my effect is running, but the UI is dead. Why? Change detection is not running, right? I don't have zone. Just that you know like why it was working before. So I have my digits. There was a call in my template. So in my template I called that computation, and therefore I received the value, and I call it whenever the button is clicked because zone would execute. So zone is gone now, and I need to figure out a way how to fix that. But first let's recap what we learned about computed. So, you saw a computed is pretty simple, a simple function, 0 argument function, and if you set a signal, this dependent computed where the signal is in will update. Let's look at it. I have 2 signals, a number signal and a Boolean signal. And then I create my computed. And when I do that, nothing happens. Nothing happens because computeds, same as observables, are lazy. They evaluate only if somebody uses them. I don't use it, I just create it, so nothing happens. If I use it, if I call that computed the first time, following stuff happens. Same as with an effect, before I run the computation, I say as a computed, I am now the active context. I move myself in this global variable and place a reference to me there. And then I execute my computed content. And in my content there are 2 signals, the number signal and the bool signal, and both of them, when they get the value, will pull the active context in their observers. And after that step, I have all my 2 signals here, and the computation is in their observers. So now in the next step, if I would call one of those functions, if I would set either the number or the Boolean value, as you can see, they both have a connection, my computation would run again and would return me a positive or negative number, depending on what my states are. This is a computation. Okay. So I showed you before that the app would break if I remove zone, or let's say if I unpatch this one button. I could also do it with the whole app. And how can we use then signals in Angular with this fine-grained reactivity? Because fine-grained reactivity means there is no top-down evaluate the whole app for changes again and again and again. There is really a change to one specific binding, and only this binding updates. This is what I want to demonstrate to you, how to do that with signals. 2019, I believe, we already shipped the same concept with Rx Angular. So with Rx Angular we have tools, directives, and pipes. I also initially wrote the package, the component package for NGRX, which also serves those pipes, but they are not as fine-grained as in this version. And with these two things, with the pipe and the let directive, I want to show you how signals can work. How signals can work on a fine-grained level. So, first of all, I need a render function. When I receive a value inside of a component, I need to update this component. And I have two ways how I can do that. One is the push pipe or a pipe that I will demonstrate to you. This is, I believe, one of the first features that will also land in Angular. So Angular will adapt the async pipe that it also consumes a signal. This is what I believe. It is very logical, and I want to demonstrate to you how the push pipe implementation works. So, I quickly go into my code and I disable both of my buttons. So now this one component has no zone patched bindings anymore and will do nothing. I will test that quickly by clicking the buttons again. Yeah, beautiful, nothing happens, but my side effect, if I click here again, the update comes. Perfect. So, what I can do now is, I can go here and instead of calling the digits, I can just say push. And with this push pipe, I consume the signal and internally I run change detection. And I want to quickly show you how the implementation is sketched. Of course, when we release that in Rx Angular, it will be a little bit more code, a little bit more tested, a little bit more flexible. But here you can, with the minimum working version, already see how easy it is. So I have a pipe, and in that pipe, I basically receive my signal. And then I say, if this new signal is different from my previous signal that I received, I will do something, otherwise I will immediately return. And if the signal is different, I unsubscribe from a potential previous subscription signal, whatever, and then I create an effect. In that effect, I have to call get on my signal, and this marked line here is the connection. Because of this very marked line, I can subscribe to changes. I will assign the changes to this value variable here, and then I will update my view. And when the view update is done, I call detect changes depending on if there is a new value, a different value, or no different value. Like I would not update the screen for 2 times 0, right? Makes no sense. Okay, I do that, I go back and I click that button, and we see that the number's working again. This is the first version of Angular based on signals that runs zoneless. And that's pretty cool. How does it work? Quickly. What's the time? No time. Okay, how does it work? This is the async pipe. The async pipe goes bottom up, mark dirty, top down, re-evaluating. Top down zone kicks in, application ref tick is called, boom, we re-render everything. Not really nice. What can we do? We can switch to the push pipe. We can call detect changes directly, so only this one single component will get updated. This is what we did. But there is a better thing that we can do, we can also do stuff with directives, and I will show you why directives are the cooler animal here. So, first, you see that numbers here, this number here and this number here is basically the number of template evaluations, and if I click that button with the push pipe, we already see that not the full app is evaluated, but only this very component here is evaluated, and this is also what Alex and Pavel mentioned in their talks. This could be a very nice improvement if we can go more fine granular with detecting changes. So, there is another way to write all of that, and I just need to find the component. Oh, here, poo. Okay, so I need a wrapper div, and inside of the div I can say rx let, and here I basically put my signal. I put my signal, I don't call it, I just put it there, and I can say let me generate that thing, and I will call it digits. And I will wrap that around my for loop like this, and I can remove the push pipe. So, a quick check if I implemented it, let directive, yes, perfect. Okay, so now I have this ditch variable, I can use that here, and it should compile again, I'm happy about that. And now if I click the button, I don't expect neither this nor that value here to update, because I only want to update on binding level. Real fine-grained reactivity in Angular. I click the button, no number changes here, and no number changes here, only the number in the counter. This is fine-grained reactivity based on signals. Just as a memory, we shipped that stuff based on RxJS already 3.5 years ago. But what is theoretically happen and what is happen under the hood, let me quickly show you the implementation detail. So I have my, as a structural directive needs embedded views and that stuff, I have my embedded view handling here. This is not really interesting, just that you see we need an embedded view. But what is interesting is that I receive a signal in my input binding, I check if it is different from the last one, if it is different, I unsubscribe, subscribe it again, and I have my effect here, but in this very case, I don't call detect changes on my change detector ref, I call detect changes on my embedded view. So this is the trick how you get real fine-grained reactivity. Let me quickly sketch that with the slides and then get to a point. Okay, so again a component tree. With the push pipe we were already able to do on one component. Now we need a little bit more visual context. We have green square component, dots, view container ref, dashes, embedded view. If I zoom in a component tree into one single component, we have like a value binding and two structural directives. And if I zoom into that stuff even more, we see structural directives are view container references that hold one or many embedded views. And as you know, embedded view has a method that is called detect changes. And in this way, I only update this very template snippet and not the full component and not the full app. Real fine-grained reactivity. Just to compare, on the right side, it's on the screen, it's different. On the right side, you see the push pipe, it is already reducing to one single component, really nice impact. But with the let directive, we can one step further, and this is what I would call real fine-grained reactivity. This is what I would love to see baked into Angular and running without zone. bright future, let's recap what we learned. I showed you how Angular publishes signals, what people did already in the internet, and we learned about the building blocks, about the signal. A signal on its own is useless, about an effect. If an effect basically wraps a signal, and if you get a signal in an effect, you create a branch in the tree. You basically connect the effect to the signal, and it will get notified and re-executes if you change that signal. I showed you pretty cool implementations in Angular, pipes and directives, and how you can run change detection based on that. This change detection that I demonstrated here, by the way, will not really scale in a big application, but Rx Angular has a couple of optimizations on top that it scales. It's just too much code to demo. I demoed change detection with two different pieces here, with the push pipe and the let's directive. And that's basically it for my talk. If you want to try it out with RxJS fine-grained reactivity, download Rx Angular today and start it. If you want to try it out with signals, download it in a couple of weeks, and you can also try it with signals. The core team would be happy if you give it a star, so please do so. And other than this, that's it. Thanks for your time. It was really cool to be here again, and I hope you had fun.
Thank you, Michael. That was really amazing session.